Okay. Yep. Is it all good on the?
Yeah, thumbs up.
Okay. Thanks, Tiana. Okay, cool. Hey, thanks everybody for coming to this. It's really fun to be back at NI. Not only was I part of the original OWASP type stuff, but I used to work here, and I did two separate tours of duty at National Instruments. So excited always to be back here. Hey, why did you come here today? Could just someone shout out a couple things? Like, why did you come? Like, could be tacos, could be wanted to learn something, interested in AI. Yeah. Okay. Yeah, cool. Okay, that's great. All right, yeah, great. All right. Yep. Uh, First time. Okay, that's wonderful. Wonderful. Yeah. Okay. Okay, cool. Yeah, right on. Yep. Yeah. And in terms of security, yeah, that's great. Yeah. Yeah, we'll definitely talk about that. Anybody else got anything else? The tacos. Yeah, yeah, okay. Learning. Okay. First time. All right, cool. Yeah. How we're improving SAST. Okay, yeah, yeah. It's a really, really fun time. You know, I don't know if I've ever been more excited to be in security or technology or anything than I am over the last, let's call it 12, 18 months right now. It's like, it is incredible, the new stuff that's coming out, the stuff that we're seeing discovered just kind of at a, industry-wide scale. Like it's really, really fun. So, hey, who am I? I started a company called DryRun Security along with Ken Johnson. Right.
Hello, people. There we go.
Cool. Is that good on that? Let's see. All right. All right, cool. Yeah, so started a company called DryRun Security. Oh, and I should say this is my first time giving this version of the talk, or this talk really in general, and I'm doing no speaker notes and no like pre-head things on this because of the Zoom share stuff. So I may like stutter around on the slides here, so please forgive me on that. But started a company called DryRun Security. Ken Johnson ran internal security over at GitHub. I've kind of been in the AppSec space. I've worked at Signal Sciences and at Verica, also worked at National Instruments and Mentor Graphics, one of NI's competitors. And I started LastCon along with Josh back in 2010, right? Yeah, okay, because it was 15. And we started it for a really mature reason of spite. And it's because we really wanted to have the national OWASP conference here, and they were like, no, you guys can't do it. You're not ready for it. You know, it's a real big thing. You guys are not able to do it. And we're like, wait, we've been running a chapter for a long time, and it's really good. And Josh is way more mature than me, so like between the two of us, we should be able to handle this, you know. And they were like, no, not going to happen. So we like started LastCon, and then that was a big success. And then in 2012, we had the OWASP national conference here, which was really fun. And then after we had it, we said, you know what, that was once was enough. Like it's a lot of work, so maybe other people should do it in the future. So I don't know. Does that more or less summarize? It kind of glosses over the facts of things, but okay. So I want to talk about a little bit about the moment that we're in, that we find ourselves in technology right now. So AI assistants are appearing in every IDE. We're seeing code volume increase. Code velocity increase. Review time is going down for like the amount of time you actually have to review code changes that are coming in. Most people are kind of even skipping that in a lot of ways. From my point of view, I'm seeing a lot of the legacy SAST distrust as at an all-time high. Like I don't meet anybody that's really happy with it. I think WAF used to be the most hated category in security, in application security. I believe it's SAST now. And the stuff that so I'm going to mix some. I hate like vendor presentations, but I am going to mix some like things that I'm hearing from the field. And sorry, you know, but like people come to us and they're often talking about like breaches that matter that are really important, and they're like logic type flaws. Like they're not like coming and being like, hey, we're having some SQLi, right? Like that's not the conversation that people are having right now. Okay, so where are we going in the next 40 minutes or so? And I'll try to be maybe good on the clock there. But why is pattern matching not working in the AI era? Why probabilistic scanning beats deterministic scanning? I'm going to talk about contextual security analysis and about slide and kind of how we've thought about it. I've talked about this, not that anybody should remember it, but like a couple of years ago at OWASP or a year and a half ago on contextual security analysis and slide. And we have a slight update and some tweaks there. We have a SAST Accuracy Report that I'd like you to look at. We'll do demos and look at both of those things. And then we'll talk about some ideas and maybe some future-looking things for like an AI readiness roadmap and like how AppSec teams are approaching it and some ideas of like exploration that can continue to work there. So, okay, well, why is pattern matching not working in the AI era? Well, under the hood, this was like there's two of these slides, and this is like one of the funny ones. So I'm worried for you, okay? As a group, I'm worried for you. Because there's not going to be a ton of funny ones. But like Open grep is kind of like been shoved inside of all of these tools, and everybody's kind of getting the same level of results, and that's how it is. And you know, we don't need to retread like why everybody stole from SimGrep and then made it Open grep and said it was okay. We'll just kind of leave that as somebody else's fight to deal with. But AI assisted development is here. We have people using Copilot, Cursor, Windsurf, Claude Code is really good. We're seeing people touch more code paths and more repos, and we're seeing less human keystrokes on that side. So I think we're in the early days of it, where you'll have like 24/7 coding agents, generating pull requests like unattended, but that is coming. Security bugs, they're not as simple as they used to be. And I think we're going to continue to see a decline in that. Like as AI agents or AI assisted developers or AI augmented or however you want to think about it, you're going to have less like autocomplete, or like you're going to have less like typo driven errors or like unsafe memory handling or using a library in a wrong way. Like those are kind of going, the syntax errors are kind of going down. Embedded linters. I think that one general takeaway or consensus that I'm seeing is like, if it can be encapsulated in a rule or a regex or a pattern, like it can be learned. And if it isn't already, it will be. And so like that level of like application security error stuff is going away. I might have had a few like rule-based engines reach out to me kind of freaking out because they realize this too. If you're sitting on thousands of rules and that's your like IP, like that is a significant problem. And and because of this, I think pattern matchable flaws are like in decline. Okay, so that's kind of where we are now, and that's like a fuzzy state, and like it's not, like anything, it's not evenly distributed across all companies. But kind of that general ethos there is like, if it can fit into a rule, AI can learn it, and if it's not, it will. And I think that we will also see more and more of this where like AI agents will be able to refactor code in order to pass the CI checks or any sort of pipeline checks or anything that you're putting in place. So they'll be able to like interact with each other. And so you can kind of think of like AI remediating AI or AI checking AI. These are some patterns that are coming up. So let's explore a little bit more on like the difference between patterns and like unknown patterns. So like if you're able to just see like syntax, then like that, I would call that like fitting like where you can go with like a regex type based approach, but you don't really figure out intent there. Where like unknown patterns are things that are like logic flaws, things that never really existed before, or at least not in the variation that could have been easily like regex pattern matched. So in the AppSec world, in our space, you can think of transferring funds. You can think of hiding stuff in feature flags or not hiding it appropriately, or like applying the right authorization or the incorrect authorization, permissions, taking advantage of like mismatched state or misplaced state in a transaction flow, something like that in an application. And so the kind of stuff that we see And in 2025, the AppSec risk that people really, really care about and that brings people to conversations about like, well, yeah, how do I solve this? It's not too unfamiliar from OWASP top 10 stuff, like whether you call it IDOR or BOLA, you're having like tenant isolation problems, you're having race logic conditions. A lot of the ATO primitive stuff, like being able to do resource or user enumeration, that's interesting. SSRF is like on the comeback, so like that's super fun, right? It feels like a little bit of a blast from the past, but like we still are running into that a fair amount. Mass assignment, workflow abuse. I'm not going to go through all of these, but I know that not everybody has the same AppSec background and and hasn't kind of always gone through the AppSec track here. So I'm going to talk about two in particular. I'm going to talk about IDOR and SSRF and just give a few examples of like how it works so you can get an idea from like a code flow here. So what is IDOR? This is an access control flaw where you can have an internal object and then the caller, an untrusted object or an untrusted caller is allowed to access it. And so you can sort of think about it where like a user can access an order that they didn't place that is really somebody else's order. Seems like GraphQL, like that seems to be another theme where anybody running GraphQL has some IDOR or some BOLA kind of baked inside there. So here it is in code. You can see we have our owner ID, our order ID. Talking is hard sometimes, but it's able to just get called without checking like who owns it or like, is this okay, right? So it authenticates the user, but it never really checks that it's allowed to actually see the order. So again, this is like super simple just to get you thinking about the problem. And so if you were to exploit it, you would go ahead and get your authenticated session, a real user of the system, and then you would pass in your session cookie there, and then grab that order that you wanted, right? So the server happily returns the request, even though you shouldn't be able to see it. And then if you're fixing it, right, you apply some basic checks, right? That is the user ID for the owner of that order actually match the current user ID. So you can see that this is not this isn't crazy. Some people do try to write patterns for it. I know people that have like tried to figure out every way that their organization does authorization, every way they handle access to different API routes and stuff. But it can be a bit difficult, and especially with that's the tool you're struck with, because there's a lot of either human, whether AI assisted or not, there's a lot of things that can go wrong in here as like a human is dealing with this code, right? As they're writing it, they can do a lot of other things, and it causes you to break out of your pattern matching approach. So it allows us to start. Oh, I can't skip that. So okay, so let's talk about SSRF. So server-side request forgery. What is it? It lets a user supply a URL or host, and then the server fetches it on their behalf. And this has kind of become interesting because we've seen a lot of breaches in this area come up. And so here it is where we have our app, and we're just taking like the user arguments for URL, which is an untrusted input, and then going ahead and making that call for it. Which are like, okay, that's kind of interesting, but like what people do with it, or kind of the canonical example out of this is like, you have your web app or your application has like access that you don't have. It's not like, I'm not just using your server to go like, call Google or to call some other third party. Maybe I could like try to use like a cheap like web proxy that way. But what people really go after is like your keys or your backend or any of your security credentials or anything like that. So this is that 169.254 is like an Amazon construct for like an internal address you can call, and it can answer about itself, right? And so then it can become a pivot point into that. And it's not just theoretical, like this has happened quite a bit. So the Capital One breach is one that comes to mind, where they're able to grab access keys and they were able to pivot off of the SSRF using the EC2 metadata. And so we see have a couple others if you're interested in like IDOR or privilege escalation or data leakage from like Shopify and Uber Eats and Peloton. Yeah, these are all like, this is like the application, like it's kind of fun because, well, okay, fun maybe not the right word, but like it's interesting because I remember, 10 years ago, this is all like, it was all like network-based stuff that people really cared about. And like this room, this actual physical room was all like, no, the application is really important. Like it is the new landscape, it is the new foothold. And people were like, yeah, maybe, I don't know, maybe we should buy some more like network gear or something like that, right? Or yeah, if we just have enough like firewalls there. But like we are seeing that continue to move, and the movement of like the important data and the logic is being exposed to application layer, and we continue to see that come out. Okay, so yeah, so those are those like AppSec risks we care about in 2025, which we already talked about. But like, does this list resonate with anyone? Does anybody have anything that they would add to this list, or they're like, oh yeah, we really deal with whatever? So gives me a little free market research if I could ask. Yeah. What do you say? Slop squatting? Okay. Okay. Anything else? Back row there. Okay, cool. Cool, yeah. All right, so I have people come to me and they're more sophisticated, but they're like, hey, we spend a couple $100K, $500K paying out bug bounties related directly to IDOR. Could you help that number go down? It's like, okay, that's interesting, but that takes a different mental model of like how you think about AppSec, and that's always been one that hasn't always been available to us to think about, like to put like a real dollar cost on like how much it takes to triage and deal with some of these problems. And attackers are able to monetize authorization gaps faster than ever. Ken, my co-founder, talks about like at GitHub, they would pay for like a bug bounty submission that comes in, and it would like be IDOR or something on one API endpoint. And like their team would have to like really hustle to do variant analysis to find out where else is this thing, because you would have those people now submitting the same style of bug on other parts of the GitHub application. And so now instead of just one $30,000 payday, you end up with 3 of them, right? Now and you got to pay all 90K, or you broker them and you're like, hey, how about we just pay you 50K instead of the whole 90, because like you just copy pasted, right? And to think that an AI assisted bug bounty researcher is not going to be able to do variant analysis. Like you need to be able to do it really fast, and they're also going to be doing it very fast on your system as they do it. I also, as I was working on this, just a fun, like I like to share prompts when I find interesting use for them. But if you're thinking, oh, I need to like make an investment in how we deal with IDOR at my company, or how we're dealing with some AppSec problem, I just asked this I use like O3 Pro, like any good reasoning model, and just ask it for something like this. And so I asked for like, hey, provide me some real world breach reports of IDOR in the last 5 years, provided with links, so you could get back a reference to it. Anyways, that's how I generated that Shopify stuff. Like I didn't have like all the Shopify stuff in my head, or the Uber Eats thing in my head. I was able to just pull that through that. Okay, so major takeaways here. Pattern matching is for yesteryear's bugs. AI code generation is growing in both velocity and volume. And there is novel code coming out of that kind of breaks the pattern matching flow. And logic and auth flaws are dominating breach reports in a big way. And smart teams in AppSec are trying to deal with this issue today, and they're trying to make that business case in a lot of ways to like equate, like not just because like we know like when you look at anything from a security lens, and it's like, well, how much does a breach and reputation damage and how much does all that stuff cost? Those are very valid and very reasonable things to think. But like being able to discreetly say, no, we pay $500,000 a year because of this problem, like that's a completely different conversation with your team. Okay, so who's with me? We still good? Good. Keep rolling. Okay. All right. Good. All right. Why is probabilistic scanning beating deterministic scanning? So what is deterministic scanning? So it's hard-coded rules, have a lot of regexes. You basically have like this match, no match scenario, and anything that's like novel logic, it's like not going to find, right? So because everyone knows AI is really important, this is the second funniest slide, or maybe this might be the first now. I pre-warned you. Thank you for the laugh track there. I need to carry one of those like laugh buttons, like just be like, hey, I'll do it for you. This is the funny one. Yeah, so like SAST is, everybody's kind of got the word, right? AI is really important. And so they've taken their pattern matching tool and then they run that through some sort of AI system to either triage it, to kill false positives. So you go to any of the SAST homepages right now, they will all say the words AI on them and promise like that everything's better now because they have AI. But under the hood, it's basically the same game. It's AI plus a pattern matching system, whether it's homegrown or they've just kind of like retrofitted like OpenGrep or something like that in there. So, but probabilistic scanning is different. And so it's not taking that approach, but instead it's looking for evidence that it can find, trying to find truth in the system, trying to build up what it actually knows around what's going on inside the code change itself, not just looking for like strings or patterns that are like necessarily detectable. It's able to accept uncertainty in its analysis and kind of pull that data in and hold it and retain it until it can figure out like, is this relevant or not, or and can have some confidence levels. Now, there's a lot of ifs in that statement, and we've spent like 18 years of like a lot of bruises, or 18 months of like getting a lot of bruises of that at DryRun. But it's been a lot of learning has come through that for us. But it considers the environment that the change is occurring in, and we'll talk more about that. But the idea is like code is not, you're not just looking at the code, you're building up a lot of context around the code. And we'll get into like how we think about that in a framework and then a reusable framework that you could probably pull off in other areas that's not just code review. So why do context signals matter? You want to know who wrote the code, what does the app do, what is the purpose of the code change? Why is this change even happening now in our organization? Why is the code change needed? Does the code normally change? Has this developer been here in this part of the code base before? Like that's an interesting question to ask. And does this code change meet our policy? A lot of times like we have our policy that sits in our wiki or in some PDFs or some wherever, but like it's very divergent from what was actually tested when developers are writing the code. So these are like just my thoughts. Like as you're doing this, most people will kind of quote you this like 80%. Everybody in the industry is saying like, hey, we're seeing reduction in noise just applying AI principles. And I think that's probably valid, but I don't have any like hard data. This is just like my inference from that. And developers are seeing a lot lower false positive rate. So again, it's just rhetorical data. I don't have anything to share on that. I do have some more data-driven stuff later in here, but sorry. So different advantages, whenever you're doing context and you're looking at probability based analysis, you can start learning the conventions of the code. You can learn the conventions of that organization. You can look at anomalies that are well past anything you could figure out with regex, and it's looking at risk and not really line count. So I think like as we think about probability and context, you can think about things like scoring, doing contextual reasoning. I'm going to talk about slide 2.0, or I think I actually called it 1. That's a typo there, 1.1, because it's a little bit variance from our previous version of that. But contextual scanning 201, like, so if we're kind of saying, all right, how do we make this better? Well, you can also do validation, and you have both AI checking the context that you created and have an AI come in on top of that, and another agentic type approach, as you've kind of heard people talk about more agentic functionality there. And then we've also been experimenting a lot with like agentic code tool access. So like if you can't get to real truth on like what is inside of that pull request, like where else in the code base can we call? Like, okay, yeah, maybe you didn't modify the function, but like it does have authorization wrapped around it, but we need to look at like what that authorization is really doing, and are you calling it appropriately? And so giving tool chain access to these AI agents is a big deal, and being able to move your actual policy into like primitives that can actually be assessed inside of the code change. I think that's a really cool thing. So, all right, I think determinism isn't keeping up with the velocity of AI. Probabilistic analysis surfaces novel flaws, and context is a multiplier. So that's those are those kind of major takeaways from this section. All right. I'm going to talk about contextual security analysis and kind of like the 5 key areas. And it's in this really handy acronym called SLIDE to help you kind of remember it. So it's multi-signal analysis. It looks across like not just the code, but also like the developer, the design, and the intent of the change. It treats, you can kind of think of it as like, it treats it as like IR. So, we're talking about IR, it's like, it sort of starts thinking like code review can turn into IR, or like trying to find out more facts and more data and more context around that code change instead of just treating it as a one-off. So, all right, so this is surface and APIs, language and framework idioms, intent and purpose, your design and audience, and your environment. And we'll walk through each of these here. So your surface that gets changed, right? So you have the routes and the code paths that get affected, which queues you're using, which databases you're calling, where you have trust boundaries in your system. And you think of like anywhere you have like a data flow diagram, or where now like a new entity would get spun up, that is a change in your surface. All right, so for language, it's like read all the docs, like all of them, right? And that is a real interesting thing. You now have an agent who knows everything about the Go programming language, and you're not just required to just like match the known bad patterns, but Java can like think a little bit better on that. Also for every subsequent version, and all the oddities and the workarounds that have been published, both in like the actual developer documentation, and then what we've seen like pop up in like security incidents. All right, intent. So intent is more of the softer side of it, right? Like why did the human, the person, decide to make this change? So what was the business purpose of it? What is the new, like how is the user going to experience it? What is the functional intent of the code change that's being made? We also like to think like how did it get here? Like what led up, like what business decisions led up to this point? What tickets or what trail could we follow that would lead us to discover the intent? This is the modification from the old version of Slide to the new version of Slide. Is I used to have it as detections and like discrete detections, but really backing up and thinking of like design and overall design, both like in an architectural component framework there, and understanding like what domains and trust boundaries you're dealing with. And you kind of like this edges in like the threat modeling light. So if you had a threat model, I think feeding that into a contextual security analysis engine, or making that part of it, like I think that'd be a really cool thing. Trying to remember the company who's doing like threat modeling on demand, and like I think but like in an AI generated way, and I think that's a pretty cool aspect. So I don't know why. If anybody knows that, feel free to shout it out, because I can't remember who it was off the top of my head. But I think there's a lot to explore in that area. And then the last one is environment. So you can think about this as like your infrastructure is code changes, and any configs there, CI pipeline environment config and code changes that are happening, secrets, any runtime policies you have, the type of the app, what it's doing, its purpose, and where it sits in the organization. So I thought, just to be good on time, I'll do sort of a quick demo here, but we had and I'm sorry that this is going to show some product stuff, and like I said, I try not to do that, but it'll just be inside of GitHub on a public repo. No DryRun Security UI behind it, but we had a person testing this out, and they submitted a pull request that had a bunch of security vulnerabilities for like GraphQL, missing authorization, and components like that. So let's just pull that open here. There's a few things that we called out, and so we have a function of our product called code policies, which won't even talk about. We'll leave that as a whole separate thing if anybody's interested. But it looks for things like resource exhaustion, information disclosure and logging, missing authorization in this endpoint, and looking for these components. So it's starting to like pull in where it finds issues, it validates that, and then is able to reflect that back to the developer as they're writing the code, as they're committing the code and putting that in. And so this is a really exciting thing, because now, like, instead of giving a developer like, oh, hey, check like the OWASP guide or go to the cheat sheet, or giving them like results that are kind of meaningless, you can say like, no, look, you're calling this function and you're doing it in the wrong way. I like this one. I've done a lot of ops type stuff, but like here it enabled GraphQL in production, and it set the flag to true on the code change. What line is that on? So, well, I don't have my readers. Left them over there. So, anyways, we'll kind of move on past that. But it's really exciting, because now you're seeing a different type of response that developers can actually interact with. You're seeing code relevant, function relevant type response that they're seeing. Okay, so CSA and slide and kind of thinking about like design, intent, environment, it matters just as much as the code. And I think that is a really fun thing to see, because risk comes in forms that don't just match normal patterns. And I think contextual security analysis is really cool in like the code context, but I also will have some slides at the end. Like, there's other ways you can use the same type of approach for other aspects of like the AppSec toolchain, whether you're in the runtime or you're looking at other components like there. So, all right. Okay, so the next one is an accuracy report, and this is well, I keep apologizing for vendor stuff, because like, hey, DryRun Security ran it, but all the code is public. You can, as my kids would say, we have the receipts. Do they say that? Do they say that? I think they say it, right? I don't know. I have a 13-year-old and 11-year-old, and I try to annoy them, like trying to say all the latest phrases. So, anyways, all right. That wasn't funny either. So good, huh? Yes, yes. Okay, good. See, Josh, don't confuse me. You know I'm simple-minded. So, hey, why did we do another report? I think it's because we're a small startup, and people will disbelieve you, and they'll say, nah, it's not really true. And then companies with billion-dollar valuations will say that they're really great, and then we're like, wait, but that's not really true, really, And so, how do we do it, right? Well, we got to figure out some way to let people know what's going on. So we took 26 intentional vulnerability samples across 4 different languages of Python, C#, Ruby, and Java. We ran everything in GitHub in their full commercial mode, but we didn't do any like tuning. We didn't add in any extra SymGrep rules or SonarQube things. We just kind of ran them in their default state, but not in like but in a fully actionable version. And we didn't even do any tuning of DryRun Security. So we have natural language code policies, which is how you tune and find some really, really cool stuff. We didn't run any of those. Like, we just ran it like completely stock on that. And so we looked at SymGrep, SonarQube, CodeQL, Sneak, and DryRun Security. And we looked in 2 different classes. So we looked for classic stuff like SQL injection, cross-site scripting, things like that. And then we also looked for like logic stuff. So IDOR, authorization, some of the stuff we talked about today. The scoring formula was highly sophisticated. We took true positives minus the false negatives, and which is like what you got right and what you missed, and then divided by the total number of samples. So nothing crazy there. I didn't do any special weighting for like the new school of like logic, detection or like contextual security analysis stuff. That didn't get any extra priority or weighting or anything like that. So DryRun Security, we had an 88% accuracy. The next best had 46% accuracy. And I'll just show you a couple like snippets out of the report. So let's see. Whoops. Okay, this is going to be hard for me, but let's see. Go up here. Yeah, so we had our classic and our logic split up here. And yeah, let's see one other. Then all the code is available on these public pull requests, and all the reports and like breakdown of like why someone missed it or didn't miss it is all public as well. So not pulling any punches here. And then we were able to see that DryRun Security kind of got in that. So all the results are here. Yeah. So, and then a breakdown like a tool by tool how you could do that. All right. So. But I was really surprised personally. So I thought that like the classic stuff like SQL injection was everybody was going to get, and then like we would just see like some delta of like these like new school of authorization and logic flaws, and I was prepared to be like, oh, we're going to wait the results for that to be better, but it's like, no, this is a mess. Like so. Turns out, like because of all the problems of dealing with false positives over the years, people have really taken the tools and made them so that they miss so many things, and they've kind of like made them less accurate. I was surprised. I don't know. Maybe other people have different view on that, but so you can get a copy of that if you'd like, or if you hit me with an email. At the end of this, you can skip all of our marketing capture stuff, and I'll just like send it right in your inbox if you want. I'll put my email at the end here. Okay, so where does this leave us? Because like we've kind of covered a lot of ground, and thinking about like where is AI, how it's going to change the future of like software over the next 18 months, 12 months, 3 years, 5 years. Your time horizon may look different at your organization. But we're going to see more code written by more people. And there is like is somewhat of a like, I don't know, somewhat of a naive view or kind of a like just like a real basic view of like, well, people that are like vibe coding, those people are bad people and they'll make a lot of mistakes and it's going to be horrible and it's going to be a mess, right? And I think like, okay, like I'm willing to like entertain some of that discussion because like the state of like where it is today versus how people vibe code. I think it sort of it doesn't really change like the way it doesn't really change your like the way you deal with risk in that situation because I think if your organization is like hiring people who have no coding experience and are just letting them code apps for you, well, I don't know. That's not how most people are doing it. Most like senior developers or people at your organization that are like vibe coding, they're having a good time. Well, I don't know, it depends. It depends on what they're allowed to use and how they're doing it. But some of our developers are super ecstatic and having fun with it. But like you're able to build stuff a lot faster. You're able to take away some of the junk work that you don't want to do. You're able to build your testing a lot faster. And we're just seeing like higher code velocity. And so we track a bunch of stuff at our company, but we're just seeing like how many pull requests like is on average happening on a per developer basis in an organization. And we're seeing that chart. I know we're a small segment of the market and we're able to see just a small amount, but we're seeing that continue to grow. So, and security teams have to be able to scale context and not in headcount. And I think this is like a philosophical approach that we're going to have to figure out as an industry is like we weren't able to hire more headcount 5 years ago. Like that's not going to be a new thing that like we're somehow going to be like, oh, look, cool, we're just going to grab some more people and make them a part of AppSec. Like that's not going to happen. But they can take some of their knowledge and their brain and like offload some of that to a system who's able to look at different context clues throughout an organization and figure out like what is the most important stuff that's going on in my organization. So while the code base changed 1,000 times yesterday, what 5 things move the needle? What 10 developers need to be talked to? Like who's doing this? And so one of the reasons why Ken and I started the company, we had a friend of ours who was telling me this. He said, it's like, yeah, so this is like I don't know, 18 months plus ago. And we were catching up and he works at a large social media site. And I said, hey, what are you working on? And he's like, oh yeah, well, see, I'm working on like sanitizing this like RBAC system that my developers wrote. And it's like, it's completely custom for us. And I was like, oh, that seems like not what you would want, you know? And I was like, why not just use like a library or framework or some like try to pull up some system to like do your access control. He's like, yeah, I would have totally done that. But they've been working on this for 6 months and like a whole bunch of effort has already gone into this. And this wasn't like a antagonistic security and developer environment. Like it's not that at all. It's like it's very friendly, very good relationships, but developers just didn't know like they should have involved security in the conversation earlier for this. They're like, oh no, we're just trying to get access to these endpoints and this whatever. So it was like one of those classic cases, like if he just would have known, like he could have like been a part of that conversation way earlier. And so like that story, along with a dozen more, like kind of rattle around in the back of my head all the time of like, how do we make that bridge better, and like how do AppSec folks or security folks kind of like live together in that world. So we're going to see more and more like AI checking AI and the adoption pattern of that. We're going to see automated code policy enforcement, so API endpoint authorization. And for some people, I've had people say to me, they're like, oh yeah, I feel like we've cloned like our best AppSec engineer, and like they can actually like, work on the stuff that they really care about. So I think that's the kind of the new world, the new set of tools that people are looking at right now. I would say like you don't need to buy DryRun Security, but I think like considering a tool like shaped like this is something that's going to be on people's roadmap over the next 6, 12, 18 months. And how do you do it? It's like you don't have to just say we're going to rip and replace whatever pattern matching tool or whatever system we've kind of already built up, but understanding like what gaps do we already have in our system? Like what gets us? Like, is it that we're paying out bug bounties, or we have authorization flaws, or like what is it? And then evaluate like how effective that is, and then how do you fill those gaps? And some of the new school code security tools are delivering that, and they're worth looking at. I loved this whenever it first came out. This is all the way back to GPT-4, so this is like aged, right? But James Berhotti pulled up Sneak Code and just stock GPT-4 and ran code through both systems. And he ran like 5 coding examples through it. And the results were like Sneak got like 3 out of the 5, and ChatGPT-4 got 5 out of 5. And so it's like, that's pretty wild. And so you could build some of the stuff I'm talking about here if you have LLM access, and start thinking through like slide, like that is another pattern of how you could do this. So, but how do we, I kind of promised this earlier, teased a little bit, like how do you think about contextual security analysis outside of just code reviews? And like where would that really lead you if you're thinking about that? So I don't think context is only for pull requests. I think if we're thinking about inside of the SOC, you have like surface for code paths to owners as you're thinking about like what endpoints, and the moving our the types of language and things we're looking at in the incidents that are coming through, and then like being able to pull those forward into like new types of monitors we're able to go with. And then if we're like doing labeling on the different environment components that are funneling into our SOC, I think there's a lot of promise there. People that are doing SCAs and SBOMs, I think weight patching recommendations on the environment and design. I think we've really focused on reachability, and I think reachability is like, okay, that's real, but like reachability doesn't matter if it's like never actually being like a run application anymore. There's some other like components that you would flag in like an environment and design standpoint. I think ASPM platforms, you're able to see more of intent because you're able to wire in more data than just your SAST or your DAST or your WAF and your Jira ticket system and whatever. Man, I can't believe I just said all that. It sounds like a I don't know, SAST or your DAST or what. Okay. Anyways, labeling and correlation across all those events and those event streams is also something that I bet we see more and more happening in like ASPM platforms as they kind of bring all that context to bear on those problems as they're kind of getting wired together. And you kind of think about it like it turns into a bit of a knowledge graph for you, where you're thinking of, okay, I have my code review, my SOC, my SCA, my SBOM, my ASPM, and everybody's kind of contributing into that component, and like who's seeing that, and you're hopefully seeing. Maybe even duplication doesn't matter so much, but you're able to see actual signal through that, and you're actually able to grab what is really moving the needle for you and your organization risk-wise. So AI checking AI, that's going to be a thing, and that's going to be a defense tactic that I think a lot of people are going to be looking at. Automating policy enforcement, and then having a plan like how you're going to think about this, not just in a code review instance, but in like how am I going to think about this for my SOC and my ASPM, my other components. All right, so I think these are the key takeaways. So hopefully this landed, was good. I would love some feedback because like I said, this is the first time I've given this talk, so very open to that. I'll share my email here in a second. I didn't pull the Oprah meme to do this, just did it in, text here for you. But I'll send you all these PDFs and I'll give you these slides as well. But just send me an email at james@DryRun Security, and I'd be happy to do that. So, all right. I think do we have time for questions, or I was trying to
We
race
got
the
about
clock there.
5 minutes left if anybody has any questions. If not, anybody in the room want to raise their hand with a question for him?
Yeah.
And of course, it's across the room.
Thank you. Appreciate it. Thank you for the presentation, James. Just out of curiosity, do you see reachability analysis becoming more available in many of the SAST tools like yours? So, for example, you may have a vulnerable library in your application, but the vulnerability, in fact, is only impacted with maybe a certain function, and that function isn't used by your application. So is that, from your perspective, your lens as owner of business and seeing the landscape out there, is reachability, being able to like really draw it out down to the function level, is that something that is a trend and that's going to become the norms, or it's just kind of like a trend and it's going to go away and we'll focus on, I don't know. Yeah.
Okay, yeah, no, good question. Yeah, so the question is around reachability, and I think okay, so we don't have reachability in our product because we're not like an SCA type tool. But I don't know an SCA tool today that doesn't talk about reachability. So like certainly the marketing departments at all the firms have believed that this is the future. I have an alternate, a bit of a hot take here, and it's this. I'm a developer. I need to, I don't know, display an image. I could go grab a library for that, or I could use Nokojiri. That's always the bane of mine when I was doing a lot of Ruby development. But anyways, let's say I was just like grabbing that. I could also just tell like Windsurf, be like, hey, see that image library over there? I need to be able to do the display function out of that. Can you rewrite that and pump it in here? So now I own that. And so I think that we're going to see a complete shift of third-party code being inherited in our library, which is, let's call it 85, 90% of our code base right now. If you were like to, stack it all up in lines of code, and to where most of that's going to shift into like first-party code and code I own and control. And I'm just ripping out the stuff that I really care about. Is that good for the ecosystem? No. Is that good for open source? No. I think it's going to happen though, and because I would rather deal with that than like live into somebody else's timetables of like when are they going to update this like random open source package. But yeah, I think reachability is still on the table from a marketing lens for sure. Yeah.
Anybody else in the room? Anybody else online want to come off mute? I am seeing no, hearing no. So thank you very much, James.
Hey, yeah,
thanks for the
thanks.
presentation. Thanks for doing this.
All right, thanks.
And that will conclude our meeting. Hopefully see you all next month at the end of July. So thanks y'all. Thanks for attending. Adios.